Okay, so today we will discuss another error correcting method, that is called the cyclic redundancy check. Now the cyclic redundancy check is a very good method to detect the error. Okay, so cyclic redundancy check. Now I have said already in the previous class that the redundant bit is that bit, that means whenever we want to detect any kind of error, along with the data word we must send some amount of extra bit to the receiver side, and with the help of some sort of algorithm and with the help of this extra bit we can able to detect the error. Now in the previous discussion we have discussed the one dimensional and the two dimensional parity checking method, and in this method also we have appended extra bit to the along the end of the data word to make a code word. That code word is being sent to the receiver side, and so with some sort of parity checking method we are going to detect is there any kind of error from the sender side to the receiver side. Now the same concept is being applied here in the case of the cyclic redundancy check method. That means we need a data word, and obviously we need some amount of extra bit. We have to generate some amount of extra bit with the help of obviously the method I am going to discuss in the next so we have to append some kind of extra bit to the data and make it a code word, and we have to send this whole from the sender side to the receiver side, and with the help of the same algorithm that we have applied on the sender side we have to apply the same algorithm to the receiver side also, and we have to detect the error. So for that purpose what do we need? We need three things. First thing is your data. Obviously data is being needed. Okay, second thing is your CRC generator. So this is your CRC generator that we need. Okay, and third one is your CRC bit. Okay, so these three things we require. First one is your data bit. Okay, and second one is your CRC generator. Why we require the CRC generator we will learn in a few minutes, and we require CRC bit. Okay, now the CRC bits is being generated at the end of this algorithm, and we have to append this data. At the end of this data we have to append the CRC bit, and this whole data plus CRC bit is being sent from the sender side to the receiver side, and in the receiver side also we have to apply the same algorithm to detect is there any kind of error or not. Okay, so this is the whole process. Cyclic redundancy checks, this is the process. We need data word, we need CRC generator, we need CRC bit, and at the end of the process from the sender side we need append that at the end of the data CRC bit, and this whole block is being, this is a code word, and this is sent from sender side to the receiver side. So this is the process. Okay, now CRC generator. Now if the CRC generator length, okay, if the CRC generator length, okay, is n bits, if the CRC generator length is n bit, okay, then the CRC bit generated at the end of this process or the end of this algorithm to the from the sender side is n minus 1. Okay, so if this is 4, this is your 3, likewise in this way. So this is the CRC generator, about the CRC properties of the CRC generator and the properties of the CRC bit. Now how the CRC bit is being generated, that is the our algorithm main aim of our algorithm. So for that purpose CRC bit, now the CRC bit is being generated, this is the CRC bit. So your CRC bits is being generated by with the help of this process. So we have data word obviously that is going to be sent from the sender side to the receiver side, that is our raw data. Then we append at the end of the data n minus 1 0. If the length of the n minus 1 CRC generator, length of the CRC generator is n bit, So we append at the end of the data word n number of zeros. Okay, then we divide this whole with the CRC generator. Then we have to divide this whole with the help of this CRC generator. Okay, so it is become data plus, suppose CRC generator is 4 bits, so you have to append 30 at the end of the data divided by CRC generator, divided by CRC generator. Okay, and you have to send, then CRC bit is being generated, then you have to append the data plus CRC bit, and we have to send the whole to the receiver side. So I am again repeating all this. The cyclic redundancy check, we need data, we need CRC generator, and with the help of this data and CRC generator we have to generate the CRC bit, and then at the end of the data bit we have to append the CRC bit, then we get the code word from the data word. Okay, and we have to send this data plus CRC, that means the code word, from the sender side to the receiver side. Now what is the process by which we can generate the CRC bit? That is most important to us. For that purpose we have the CRC generator. If the length of the CRC generator is n bits, then the CRC bit is n minus 1, then the CRC bit is n minus 1. Suppose the CRC generator length is 4, then the CRC bit is 3. Okay, now how the CRC bit is being generated? So the CRC bit is being generated, that means the CRC bit is equal to data plus n minus 1 zeros. Now what is n? N is the CRC generator length. Okay, so you have to append data plus n minus 1 zeros and divide the whole with the CRC generator, then we get the CRC bit. So data plus n minus 1 zeros means data, and here our CRC generator length is 4 bits, so you have to append the 30 and divide this whole with the CRC generator, then you get the CRC bit. Then data plus CRC sent from sender to the receiver. Okay, now at the receiver side the same process is going to happen. So this is from the sender side. Now at the receiver side what happens is that your data, I have said that data and whatever the CRC bit is being generated by with the help of our algorithm, the CRC bit that is being sent from sender to receiver. So receiver receive data plus CRC bit. Okay, then what process is going to happen in the receiver side? So data plus CRC bit is going to receive by the receiver, and that is also divided by this CRC generator. This is also going to divide by this CRC generator. Okay, now if the remainder, here this is the remainder, CRC bit is the remainder. If you divide this data plus 000 by CRC generator, the remainder is the CRC bit. Okay, not the quotient, remainder is the CRC bit. Now here data plus CRC bit is being received by the receiver, and we have to divide this whole by the CRC generator. Now if the remainder, again if the remainder, this is the remainder. Now if the remainder is 0 0 0, that means the whole 0, then we can say that correct data is being received by the receiver. Now if the remainder is not 0, somehow if the remainder is not 0, then we can say that there is some error is being happened from the sender side, from the receiver side, when the data or the code word is being transmitted through the unreliable transmission medium. So this is the whole process. We will see an practical example so that it is very much clear to you. So we need data. First we need data. So this is your data. So data is, I have taken data is 10 11 arbitrary. This is totally arbitrary for the example purpose. First is your, we need data. Second one is your CRC generator. Now the CRC generator, length of the CRC generator, we have taken the length of the CRC generator at 4 bits. So that's why this is 4 bits. 4 bits is 1101. Suppose we have taken 1101. So this is your CRC bit. This is your data. Next, length of the CRC generator is 4. You can see length of the CRC generator is 4. Now I have said that if the length of the CRC generator is 4, then the CRC bit is going to be generated at the end of this process from the sender side is 3. So see, length of the CRC generator is obviously 3 bit that is going to be generated at the end of the process. Okay, so that is the whole thing. Now in the division is going to be happen. I have said that here division is going to be happen. You can say division is going to be happen. In the case of the division, we only interested in the remainder, not in the quotient. So that's why this division process is an XOR operation. So whenever you perform the division operation, whenever the computer perform the division operation, it performs the XOR operation. How? I will tell you now. Okay, so this is your data, and this is your CRC generator, arbitrary taken CRC generator 1101, and this is your data, arbitrary taken CRC generator, and the length of the CRC generator is 4 bits. If the length of the CRC generator is 4 bits, then I have said that the CRC bit that is going to be generated from the sender side is 3 bit. So that is written down here, 3 bit. And the division process, we are not interested in the quotient, we are interested in the divisor or the remainder. So in the division process that is going to be happen, we are perform with the help of this XOR. Okay, XOR operation. XOR operation, with the help of the XOR operation we are going to take in this whole division process. So how the CSC bit is going to be generated? Okay, so our CRC generator is 1101 and our data is 11 sorry 10 1101 1101. Now in the process, whenever we discuss the process, we have said that n minus 10, that means 30 has to be appended at the end of the data. So 30 is to be appended 0 0 0. Okay, and this is your CRC generator, this is your data, and this is your, this is up to this is data, and 30, this 30 has to be appended because this is the process. Process says that if the length of the CRC generator is 4 bit, then you have to append the 3 zeros at the end of the data, then you perform the division. Okay, so we have not interested the quotient. For that purpose we will not write down the quotient here, so I'm just changing the color. So 1101, so 1101 perform the XOR operation. I have said that for the division purpose we perform the XOR operation. So just perform the XOR operation, same number 1 1, that means 0 0 1 1 0 1 1 0. Okay, now this 0 is being discarded from the left hand side. The 0 is being discarded, we only taken this 0 is being discarded, we only taken 1 1 0. Then this is 4 and this is 3, that's why this 0 will coming here, this 0 will coming here. Okay, so again 1 1 0 1 1 1 0 1, again XOR. So 0 1 1 0 0 0 0 0 0 0 0 0. So all the left hand side 0 has been discarded again, all the left hand side 0 has been discarded again, and this one has been coming in, this 0 has been coming in, this 0 has been coming in. Okay, so 1 1 0 0. Okay, so again 1 1 0 1, so 1 1 0 1, again perform the XOR operation, again we are performing the XOR operation. So again 0 1 1 0 0 0 0 0. So whole left hand side 0, all the 0 has been discarded, this 0 has been coming in. Okay, so now you can see there is 2 1 and 0, 2 bit, and here is 4 bit. So you stop here because there is nothing to do after that. Now here is the thing is that here 0 1 0, I have said that if the length of the CRC generator is 4 bits, the CRC bit is being generated remainder is the CRC bit. So CRC bit is being generated by 3 bits. Now here 1 0, so we have to take an extra 0. We have to take an extra 0 from here to make it 3. So your CRC being that is being generated. Okay, CRC bit that is going to be generated is 0 1 0. Okay, the CRC bit is CRC bit is 0 1 0. Hope you understand the process how the CRC bit is being generated with the help of this. We are not only interested into the remainder, not the quotient. That's why you have not written down the quotient. Whatever may be the quotient, that is not important to us. And we perform the division. We perform the division process with the help of this XOR operation. Okay, so that is all about from the sender side to the receiver side. So the receiver side, what the receiver get? Now what the receiver get? What the receiver get? Receiver gets data plus CRC bit. Receiver get data plus CRC bit. Now what is the data? 101101. 1011 sorry 01101 101101 along with this CRC bit 010. CRC bit is 010. So this is your total code word that is received by the receiver. Here I have said the receiver receive data plus CRC bit. Okay, and again divided by the CRC generator. So this is the total code word that is being received by the receiver, and the receiver again performs the same operation. That means it is going to divide this by 110. So 101101 101101 and at the end it is 010. Okay, 11101101, that is 1010, and it is divisor is 1101. This is the CRC generator. So again perform the same thing. So 1101, perform the XOR 0 1 1 0, discard this and coming this, again perform the same thing. 1101 1000, discard all zeros. Okay, discard all 0, and so we have 1. Okay, so we have 1, and then this one is been coming here, this 0 is been coming here, this one is been coming here. So 1101, say again 1101, so it is all zeros. This 0 is being coming here. Okay, so what is left? The result is all 0. We can see the result is all 0, and I have said that if the after division, if the result is all zeros, then the receiver knows there is no error. So that is being implemented here. The same concept is being implemented here, that there is all zeros, so the receiver exactly knows that there is no error. Now what happens if there is a error? Now what is the error? I am just changing the bit. So the 1101 is your CRC generator, and next this is I am changing. Here you can see 101101. So 10 instead of 0 I have written down 1. Okay, so 1011. I'm just changing some of the data bits. I am changing. So 1101 1101 1101 01, and after that So previously it was 1 0, now it is 1 1. Previously it was 1 1, now it is 0 1, and it is 0 1 and it is 0 1 the same. So bit has been changed, so somehow bit has been changed in the receiver side. I am intentionally changed the bit to show you how the remainder is not 0. Okay, so you can see the bit has been changed. Okay, and this is the CRC bit that is being appended after the data. So again the same operation, 1101 1101, and perform the XOR operation. If you perform the XOR operation, it is being all 0, it is all zeros. Okay, so discard all zeros, discard all zeros. So if you discard all zeros, 1101, so here it is coming 1 0 1101 up to this 1101. Okay, so 1 minute. 1101. So this 0 is being coming here, this 1 is being coming here, this 0 is being coming here, this 1 is being coming here, 0101. So again 1101 XOR. Okay, I'm going to XOR all this and perform 1000. Okay, 1000. So again perform this operation 1101. So after that 1010. So discard these zeros and make this 0 here. So 1010, so 1010 and again 1101, then again XOR this. So 110, sorry, 1110. Discard this and we left with this. So the remainder is not 0. You can see clearly that the remainder is not 0. Now you can see very clearly that we have changed some of the data bits. That is being corrupted. You can see that whenever the data is being transmitted from the data plus code wire, data plus CRC bit, that means this bit, whenever this bit is transmitted from the sender to receiver, some of the bits in the course of the transmission from the through the unreliable media is being changed. Now if this has been changed, this is our, I have arbitrarily taken, this is our received code word. Now this received code word is not same, whatever we want, this is not actually the received code word, and we have performed the same operation. Then we get, here we get all the zeros, but here we don't get all 0. Why we don't get all 0? Because algorithm actually fails. Why fails? Because actual data that is going to be received, from the sender to the receiver is changed in course of the transmission. So that is our intention. We want to detect the error. If there is an error, we discard the data, the receiver discard the data, receiver does not accept the data and asks the sender to send it again, and that is all happening here. Okay, so you perform on your own, and by some sort of extra bit or some sort of other bit that I have mentioned in this example, and check on your own whether it is working or not. Thank you.